Hey guys, welcome back. Let's do the last few problems on this relearn assignment. So this one down here, we already did the addition problems. So let's look down here. We have subtraction. Remember, whenever we have a subtraction problem, we always use that keep, change method with every subtraction problem. So looking at this, 37.2, I'm going to keep it the same. And I suggest you rewrite these because we're going to have to set it up like these up here. And it's really important that you write it out like this to make sure you keep the signs right and know what you're going to be doing. So keep the 37.2 the same. Subtraction becomes addition. I change the sign of the following number, the second number. Now look, this is an addition problem now, but I remember whenever I add numbers with different signs, I'm not really going to add them. When the signs are different, I really have to subtract them. So I'm going to write over here just for space. So whatever number is the larger number, that one goes on top. The 51.36, that's the larger number here. I'm going to put it on the top. 37.2, I'm going to put it down below. And notice how the decimals are still lined up. That's really important whenever we add or subtract any kind of decimal. And the signs are different, so I know I'm really going to subtract these. I'll add zeros and empty spaces, and now I can just go subtract them. 6 minus 0 gives me 6. 3 minus 2 gives me 1. 1 minus 7, I can't do that, so I'm going to borrow from 5. That becomes 11. 11 minus 7 gives me 4. 4 minus 3 gives me 1. Then I'll bring the decimal straight down. Now, it's easy to forget this, but it is important. Whenever I'm looking at this, I have to make sure I have the right sign. I keep the sign of the larger number. The larger number in this problem is the negative, so I'm going to keep a negative right here. Negative 14.16. Let me write that right here as my answer. There we go. Now, let's give that an erase. Let's do the next one. This is also a subtraction problem, and whenever I have a subtraction problem, I have to turn it into an addition problem. Because, again, we know the addition rules. We don't know the subtraction rules. So, looking at this, we use that keep, change method. So, I'm going to keep the negative 8.7 the same. Subtraction becomes addition, and change the sign of the following number. So, now it's negative 12. So, let's look at this. Do I have the same signs or different signs? Well, they're the same signs. If they're the same signs, that's great. I can go and add them like normal. I don't have to subtract. I'm adding because the signs are the same. So let me go set that up. Now, whenever we add, it doesn't actually matter what number goes on the top. All right? If you always are in the habit of putting the larger number on top, though, that's a good idea. So if you want to put the 12 up top, that's great. And then 8.7. Notice how I line up the decimals. Look, there's no decimal over here with the 12. When there's no decimal written, I know that there's an understood decimal right afterward. And then, of course, there's an infinite number of zeros after that. So 12.0, 8.7, the signs are the same, so I'm really going to add these up. I'm adding two negatives, so my sign and my answer is going to be a negative. So 0 plus 7 is 7, 2 plus 8 is 10, carry the 1. 1 plus 1 is 2. Then I'll bring the decimal down, and I get negative 20.7. Let's look at the next one. Negative 5.7 minus negative 72.314. Now, if you don't rewrite this using that keep, change, this could really confuse you. It could really mess you up. So keep the first number, negative 5.7. Subtraction becomes addition, and change the sign of the second number. This is now positive 72.314. So look, are the signs the same or are they different? Well, they're different here. When the signs are different, I had to set up a subtraction problem. If I didn't rewrite this, I might have assumed the signs were the same. I might try and just solve it that way, but that can really mess you up. So rewrite it just like this. It will keep your signs straight and make sure your work is good. So I'm going to set this up. It's a subtraction problem because the signs are different. Whenever I have a subtraction problem, I have to make sure that the largest number goes on the top. The largest number in this case would be this one, 72.314. I'll put 5.7 down below, and notice how they're still lined up, the decimals. Make them a little larger so they're a little more noticeable. The decimals are still lined up. So I'm going to go and fill in empty spaces with a 0, and I get to go start subtracting. 4 minus 0 gives me 4. 1 minus 0 gives me 1. 3 minus 7 I can't do. I'll borrow. Now this is a 13. 13 minus 7 gives me 6. 1 minus 5 I can't do. I'll borrow again. Now this is an 11. 11 minus 5 gives me 6. 6 minus 0 gives me 6. So I'm left with 666.614. And is my answer positive or negative? Let's see. It looks like I keep the sign of the larger, and that one's going to be a positive here. So 66.614 is what I'm looking for there. Let's look at this one. This is multiplication. So whenever I multiply, I don't have to line up the decimals when I multiply. So I'm not going to set it up like this. You could. It's just going to give you a lot of extra steps. Instead, what I'm going to do is I always put the number with the most digits on the top. The number with the most digits here is, let's see, I got 1, 2, 3. I got 1, 2. So this one right here, I'm going to put it on the top, 3.29. I'm not going to line up the decimals. Instead, I'm just going to line it up to the right side of the problem. So the 9 and 8 are on top of each other instead of the decimals being lined up. This is how we multiply. 8 times 9 gives me 72. 8 times 2 gives me 16 plus 7 gives me 23. Carry the 2. 8 times 3 is 24 plus 2 is 26. Now, I am no longer working with the 8. Instead, I'm moving over to the 2. Because I'm moving place values, I'm going to set a 0 right here because that's going to tell me that I'm moving over to the 2. So I can just go and start multiplying. 2 times 9 gives me 18. Carry the 1. That's a 1 now. 2 times 2 is 4 plus 1 gives me 5. 2 times 3 is 6. I add these up. 2, 11, carry the 1. 11 plus 1 is 12. Carry the 1. 8 plus 1 is 9. And now, this is the tricky part. Where does my decimal go in my answer? Whenever I'm doing a problem like this, the decimal, I figure it out because I look at the problem and see how many numbers are behind the decimal in the problem. I got, let's see, 1, 2, 3 numbers behind the decimal in the problem. I want 1, 2, 3 numbers behind the decimal in my answer. Now, I have to remember, is my answer going to be positive or negative? Let's look at the problem. I have a negative multiplied by a positive. When the signs are different, I keep a negative answer. So negative 9.212. Let's look at the next one. Negative 1.9 times negative 0.356. So I'm going to put whatever number has the most digits on the top. This one has 1, 2 digits. This one has 1, 2, 3, 4 digits. This number goes on top. 0.356 times 1.9. Notice how I don't line up the decimals. I line it up with the right edge of the problem. All right? So let's go and multiply. 9 times 6, that gives me 54. Carry the 5. 9 times 5 gives me 45. Plus 5 gives me 50. Carry the 5. 9 times 3, that gives me 27. Plus 5 gives me 32. 9 times 0 is 0. Plus 3. And now look, I'm no longer dealing with the 9. Instead, I'm moving over to the 1. So I'm going to put a 0 in that place and move over to the 1. 1 times 6 is 6. 1 times 5 is 5. 1 times 3 is 3. 1 times 0 is 0. I'll go and add these up. 4 plus 0 is 4. 0 plus 6 is 6. 2 plus 5 is 7. 3 and 3 gives me 6. Great. Now, let me go and see where my decimal goes in my answer. I'm going to look in the problem, how many numbers are behind the decimal in my problem. I want that same amount of numbers behind the decimal in my answer. So let's look at this. I got 1, 2, 3, 4 numbers behind the decimal in the problem. I want 1, 2, 3, 4 numbers behind the decimal in my answer. And right in front, I'll add a 0. Because remember, you can have as many zeros in the front of your number or in the back of your number, and it doesn't change the number at all. And is it positive or negative? I have a negative times a negative. So that's going to give me that positive right there. Let's look at this one. Again, whatever has the most digits goes on top. It looks like that's this one right here. 9.835 times 2.1. I'll go and multiply. 1 times 5 gives me 5. 1 times 3 gives me 3. 1 times 8 gives me 8. 1 times 9 gives me 9. Done with the 1. I'm going to put a 0 right here because I'm moving over to this place. 2 times 5 gives me 10. Carry the 1. 2 times 3 gives me 6 plus 1 is 7. 2 times 8 gives me 16. Carry the 1. 2 times 9 is 18 plus 1 is 19. Now I'll go add these up. 5, 3, 15. Carry the 1. 16. Carry the 1. Yep, 1 plus 9 is 10. Carry the 1 again. And 2. Now, I'm going to go and count how many numbers are behind my decimal in the problem. I got 1, 2, 3, 4. So I want 1, 2, 3, 4 behind the decimal in my answer. Now, is my answer going to be positive or negative? Let's look. I have a positive multiplied by a negative. When the signs are different, I keep a negative answer. So we're looking for there. Let's look at this one. Now we're moving on to division. So whenever we divide, the first number goes inside the division box. So 6.56. Let me write it over here, actually. I need to write it over. Let me give this just an array so I have plenty of room to write. Now, first number goes inside the box, 6.56. Second number goes outside, 0.2. Now, if the number on the outside is a decimal and not a whole number, I have to move it to make it a whole number. If I do it on the outside, I have to do it on the inside. So this problem is now 2 into 65.6. Now I just get to go divide. 2 into 6, that goes 3 times. 2 times 3 is 6. Subtract, I get 0. Bring down the 5. 2 into 5, that goes twice. 2 times 2 is 4. Subtract, bring down the next number, 6. 2 into 16, that goes 8. 2 times 8 is 16. Subtract and get 0. Oh, great. No remainder. I'll bring up the decimal from where I moved it. So now I have 32.8. It's a positive times a positive, so I know my answer is going to be positive. Let's look at the next one. Let's see. The first number goes inside the division box, 94.68. 0.04 on the outside. Now, if the number on the outside is a decimal, I have to move it to make it a whole number. I'm going to move it 1, 2 spaces to make this a whole number. I'm going to do the same thing on the inside, 1, 2 spaces. So now I have 4 into 9,468. That's my new problem. And that's where I move my decimal. I'll bring it up so I don't forget about it. That's where it's going to go in my answer. So now I can go divide. 4 into 9, that goes twice. 4 times 2 is 8. Subtracting it 1. Bring down this, the next number. 4 into 14, that goes 3 times. 4 times 3, that's 12. Subtract and get 2. Bring down the next number. 4 into 26, that goes 6 times. 4 times 6 is 24. Subtract and get 2. Bring down the next number. 4 into 28, that goes 7 times. 4 times 7 is 28. I'll subtract. Get 0. Oh, great. No remainder. Perfect. So 2,367 is my number. There's my decimal right there. I don't have to keep going or add zeros because it ended with no remainder. So now I just have to double check. Is my answer positive or negative? I have a negative divided by a positive, so I know my answer is going to be negative. Those are just those integer rules that we learn, right? Different signs. When you divide or multiply, it gives you a negative number. Let's look at the last one. First number goes in the division box, 15.3. Second number goes on the outside, 0.03. So, looking at this, the number on the outside, it is a decimal, but we can't have that. We got to make it a whole number. So, whatever I do on the outside, I go on the inside. I moved it 1, 2. I'll move this one, 1, 2. Hey, there's no number here. Whenever that happens, add a 0. So now, my new problem is 3 into 1,530. And that's where I moved my decimal. And that's where it's going to go in my final answer right there. So now I can just go and divide. 3 into 1, that goes 0 times. So let me look at 3 into 15. That goes 5. 3 times 5 is 15. Subtracting a 0, bring down the 3. 3 into 3, that goes once. 3 times 1 is 3. Subtracting it 0. Now look, this is before the decimal. This is 0. When that's the case, I have to bring it down and include it. So now look, 3 into 0. That goes 0 times. 3 times 0 is 0. I'm going to subtract and get 0. But look, this is a remainder of 0. I don't have to bring down any zeros, though, because they're after the decimal. All right? Those don't matter. They only matter if they're in front of the decimal. I have to make sure I include them and finish when use that 0. So now I end up with a 0 remainder. So 510 is the answer I'm looking for. Is my answer positive or negative? Let's look. A negative divided by a negative. Oh, same signs. I get a positive answer. 510. All right, you guys, that is the end of the relearn assignment. Again, make sure you bring it to make test corrections or a retake for your test, okay? I'll see you guys in class.